Welcome to the Digital Lumens Lighting Controls Training module. In this module, we'll provide an overview of a successful demonstration for an advanced lighting control system in 3 Department of Defense facilities. In this short presentation, we will share an overview of the technology, the test sites, the project results, and some key lessons learned. The content for this presentation is based on an in-depth demonstration of a connected lighting system by Digital Lumens. Digital Lumens is a manufacturer of an advanced, fully integrated lighting control system. The demonstration was hosted at Westover Air Reserve Base in Chicopee, Massachusetts, and our test demonstrations were to show how advanced connected lighting systems can provide deep and cost-effective energy savings in common DoD facilities. In particular, we were targeting 60 to 80% energy savings with a fast payback, better illumination, easy installation, and high user satisfaction. A detailed technical report is in development and should be available on the ESTCP website sometime in 2023. The technology involves 3 main components. First, the smart LED fixtures include integrated daylight and occupancy sensors, onboard power metering, and wireless communication. Second, they talk to wireless gateways installed near the ceiling of each zone. These gateways are powered over Ethernet and greatly reduce the amount of control wiring needed in an installation. One gateway can serve up to 50 fixtures. And third, a controls appliance is a local device that coordinates control across all the fixtures within a facility. You can group lights together into zones and control them in tandem. Together, these 3 components allow for granular and flexible controls with very little effort for configuration. Using a fully integrated system has key advantages in that you know the components will be compatible. Aftermarket lighting controls can be hard to design and implement, and fully integrated controls can simplify the process. Each fixture contains its own dedicated sensor module, including a passive infrared and occupancy sensor and a daylight sensor that measures the illumination on the work plane. LED light bars can dim from 0 to 100%, and a wireless Zigbee mesh network enables coordinated controls. Having sensors in every fixture improves the flexibility and performance of the system. This can greatly reduce user frustration. You've probably been in a room where the lights turn off because a sensor can't see you. This happens much less often when every fixture has its own sensor. And what about your existing lights? You can integrate existing or third-party fixtures into the control system using a sensor module and circuit adapter. These control the lights at the circuit level, so you can use one platform to control all the lights in a facility. We won't spend much time on the network architecture, but for the DoD, we implemented this as a closed restricted network. This means it does not connect to the internet or to any other DoD networks. You have one controls appliance per facility. The wireless controls operate on the industry standard Zigbee protocol. This is a low power and short range protocol that operates in frequency bands similar to Wi-Fi and is designed to be stepped on by other networks to minimize interference. The control system includes a comprehensive and intuitive user interface. You can access the interface directly through a kiosk with a monitor and keyboard. This allows you to track energy usage, reprogram the controls, troubleshoot and diagnose issues, and review historical lighting performance. You can also back up and restore your settings, and it includes user account management tools. That summarizes the technology, and next we're going to cover the design and installation process. We selected the lighting hardware to meet the UFC lighting specifications, including the illumination targets, color temperature, and color rendering index. Typically, the lighting installation was a 1-for-1 replacement of the existing fixtures. In some cases, we removed lights, and others, we added some lights, but mostly it was a 1-for-1 replacement. As you'll soon see, sometimes the baseline lights really aren't bright enough. The fixture installation was straightforward and direct. Typically, this just involves removing the old fixture, replacing it and rewiring the new fixture, and tracking the serial numbers. That last step is not required, but it speeds up the commissioning process. The lights come with stickers that you can use to track on a facility printout map, and the electricians had no problem doing this during the installation. The commissioning step was done by the vendor and took about 1 day per facility. This was completed by the lighting vendor for a fee as part of their standard service offering. During the commissioning activity, they assigned lights to the zones or groups, joined the lights to the network, adjusted the brightness settings to the desired settings, calibrated the built-in sensors for daylight harvesting, and enabled the occupancy and daylight controls. Finally, we tested and verified the operation, and the lights were ready to use. Importantly, if you ever decide that the controls are not working out, you can completely disable the controls and use the LEDs as ordinary lights with the light switches or circuit breakers that you already have. For the demonstration, we retrofit the lighting systems in 3 common DoD facility types. These included a large aircraft hangar, a supply warehouse, and a fitness center, including a basketball and racquetball court and adjacent office space with troffer lighting. In the warehouse, it was very hard to see in the baseline condition. Even with all the fluorescent lights on, it felt very dark. The workers admitted to using flashlights and headlights to find parts when they were working. In the after condition, switching to LEDs increased the brightness by 6 to 7 times. This transformed the space, improved safety, and made the workers much more satisfied. Here's a side-by-side of 2 warehouse aisles to illustrate the difference. It really was that dark. You really couldn't see what you were doing. Similarly, in the aircraft hangar, it was difficult to see across the bay. There were dark shadows everywhere, and the lights were 2 to 3 times too dim. The metal halides took a long time to turn on, so they had to keep the lights on more than they wanted to in this facility. After the retrofit, it was 2 to 3 times brighter and provided a much better work environment. We had a lot of positive feedback from the maintenance staff who worked in this hangar. Switching to LEDs can cut lighting power in half. The metal halides you see here used about 440 watts when they were on. The replacement LEDs used about 210 watts at full power. But the LEDs were too bright, so using task trim, we were able to reduce that power even further, trimming the lights to 80% brightness to match the UFC target spec. The LEDs were more than twice as efficient as the existing light sources. But efficient LEDs aren't the whole story. If you implement smart controls, you can double the savings. LEDs with integrated smart controls can save over 80%. In this demonstration, we looked at 3 main automated lighting strategies for saving energy. The first, as we mentioned before, was task trimming, where you dim the lights to match an illumination target. The second is daylight dimming, where you dim in response to the available daylight. And the third is occupancy controls, when you dim the lights when no one is around. Together, all these can add up to really significant savings, as you'll see. In one example, for daylight harvesting, this is a picture of the hangar with the bay doors slightly open. You can see that as the doors open, you get some savings in the graph. The red indicates the amount of energy you save due to daylight harvesting. Here we saved between 8 and 15% on average throughout the year, depending on the facility. And the facilities we had did not have a whole lot of access to daylight. Here you see the bay door is partially open, and it really floods the area with natural light, making it possible to save energy. On the next slide here, you'll see that this is the same image underexposed to show the fixtures dimming. The fixtures dim in a horseshoe pattern in response to the sunlight to provide uniform floor-level illumination. This has very little impact on the visibility in the space, but is very effective at saving energy without any human input. Most people expect that wireless lighting controls are always too expensive. We found that integrated controls can actually reduce the initial costs compared to hardwired controls. Over the 3 test facilities, the total cost of the retrofit, including the installation and configuration, was less than $2 per square foot, and most of that cost came down to hardware. The installation effort was not that different from an ordinary LED retrofit. On the energy and cost saving side, we estimate that the total cost of the project was around $345,000 for the 3 facilities, and we estimate the savings at about $86,000 per year. So that's a $1.7 million return over a 20-year lifetime, or a simple payback period of about 4 years across the facilities. So very attractive economics on the project, and we think this has a lot of potential for the DoD. And finally, integrated LEDs are a highly effective strategy for reducing facility energy consumption. They improve the space, they provide more light with less energy, they're cost effective, and they satisfied the users. So overall, this was a slam dunk. Everyone was happy with the outcome, and we have just transitioned the ownership of the systems to the base. They are happy to keep these new lights, and we're looking for ways to help you scale and adopt this technology throughout the DoD. So that concludes my presentation, and we look forward to hearing more from you and to share with you a more detailed version of this. Stay tuned. We'll be developing a 60-minute, more in-depth look at this technology as we go ahead. So thanks again for your attention, and that's it for today.